Here's the short version. I'm going to do the short version, long version. Okay, benefits of both. Here I have 2 kilograms. This is literally 2 kilogram masses taped together. Okay, this has a mass of 2 kilograms. Okay, it has. See, I'm going to say 2.0 kilograms. That's its mass. Mass is in kilograms. Now, if I were to drop this, it would accelerate. Yes, there would be a force accelerating this thing down. How fast does it accelerate? What's its rate of acceleration? Negative 9.81, right? Okay, so the force that's acting on it is m times a, so that's going to be 2 kilograms times 9.8 is 19.6 newtons. That is the force of gravity. That must be the force of gravity causing it to accelerate, right? So that is the force of gravity, right? It's in newtons. That is the weight of the object. This is the mass of the object. Yes? It has a mass. Let's all say this. Let's all say this. A mass of 2 kilograms. A mass of 2 kilograms. Okay? A weight of 19.6 newtons. Come on. A weight of 19.6 newtons. How do you say todos juntos? All together? Is that right? Todos juntos. Otra vez. Todos juntos otra vez. Okay. A mass of 2 kilograms. I need everybody participating. I need Sarah participating. A mass of 2 kilograms. A weight of 19.6 newtons. Okay, now, here's another difference. If I go into outer space and there's no gravitational field, this will not pull my hand down. I won't feel that force holding it down, right? There won't be, I could just put it there and it will stay there. That'd be fun. Where did I put my mass? It's there. I got it, right? Yeah? You know? Okay. But if I took it and I did the shaker weight thing, yeah? Kind of a whatever it is, right? Okay. If I do that, it's still going to do the same thing. I can still take it, I can still exercise or whatever, right? Yeah, okay, anyway. I could still do that. If I shook it back and forth, it would still shake my body. It would still have inertia. It would still resist going back and forth like that, yes? Okay, so here are some other things that I would like to say about mass and weight, and then we will, let me write the formula for you, okay? Here is a formula that you can use. I think you've sort of guessed what the formula is. Weight is equal to m times g, where g is 9.8. Now, some people want to make it negative. Ultimately, when we do these force problems, we're going to make a downward force negative. Okay? I don't tend to, if I just say it's the weight, we all understand that that's downward, and I don't bother putting the negative on there because it's redundant. But it's not wrong to do that. Okay? So weight is just mg. If you want to make a triangle out of it, it's very simple. Weight, m, g, we're happy, yeah? Okay? So mass is the amount of stuff you have. If you go into outer space, you still have stuff. You can still do chemistry with it, et cetera, right? It's related to moles, really, right? It's measured in kilograms. It's measured in grams. And the English unit of mass is not a pound. That's actually weight. That's actually the force of gravity. Pounds is force. Okay? It's actually something called a slug. Isn't that crazy? And all people in the Northwest, of course, immediately imagine this mollusk with these tentacles moving slowly along the ground. Yes?
Is that where we get like a slug shot or a shotgun?
A slug? I don't know. Maybe. Maybe it is. I mean, I don't know. I don't know what the origin of slug is. I've never used slugs in calculations. Now, here is a crazy thing, okay? A slug is a mass, just for fun, a slug is a mass such that if we exert 1 pound of force, it accelerates, the acceleration equals 1 foot per second per second. Now, I want you guys to think about this. You must think. You must put this in your brain and think. This is a conceptual question. A pound is about 4.45 newtons. Okay? A foot per second squared is about 1/3 of a meter per second squared. About. It's like a foot. There's 3.281 feet. Yeah, in a meter, right? So a foot per second is a much slower rate of acceleration than a meter per second squared, yes? And a pound is much more force than a newton, yes? I could define a kilogram as the force we exert 1 newton of force and it accelerates at 1 meter per second squared, right? That's how we could define a kilogram. So now the question is, and I ask you, you don't even know what a slug is, but certainly a slug is a certain number of kilograms or vice versa, yes? So which is it? Is a slug bigger than a kilogram or smaller than a kilogram? Well, I'll tell you this, if you exert more force on it, it accelerates slower. Here I'm exerting less force and it's accelerating faster. So which one is it? Is a slug bigger than a kilogram or smaller than a kilogram? Huh? Huh? Let's go over that again. This should be obvious, right? A slug is a mass such that when I exert a force much larger than a newton, 4 times that of a newton, it accelerates much slower. I'm exerting more force. It's accelerating more slowly than a kilogram where I exert less force and it accelerates faster. A slug is bigger, isn't it? It's kind of a lot bigger, isn't it? It's like 14-ish more than, it's like 12, more than 12 times-ish, right? Bigger because of these differences here, right? Now, of course, we could consult the authorities, right? Okay. All right, let's see. Oh, come on. I need the mouse. Yeah, go do what you need to do. Okay. We're going to consult the authorities, and the authority is, of course, Google, right? Yeah. Okay, so we want to know 1 slug in newtons. And why is it not doing that? Because I need to do calculator or something like that. Anyway, it's 14.59 kilograms. Usually you just get the direct conversion, but maybe they've changed Google, right? So maybe that's different. I don't know. Okay, it's a measure of inertia. We already know that, right? It's not zero in space, so if you take a mass out in space, it still has the same kilograms, right? But it just doesn't have any force of gravity acting on it, right? And then watch this animation. I won like PowerPoint of the Year in 2002 with this. Watch what weight does. It's like, because it's weight. Yeah, comes down from the top, right? Weight is a force of gravity acting on an object. It's not zero. It's measured in newtons, dynes, and pounds. A dyne, by the way, is the force needed to accelerate a gram 1 centimeter per second squared. Is that bigger or smaller than a newton? A dyne will accelerate a gram, like a paperclip, 1 centimeter per second squared. That's much smaller, isn't it? It's 100,000 times smaller than a newton. It's unbelievably small. Weight is zero in the absence of a gravitational field, so you can be weightless. You can't be massless unless you're something like beauty or music or confidence. Yes? Those things can be massless, right? You know? The intangible things, right? And so the weight is m times g. That's this formula. You already have that written down, don't you? 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 Yes. You guys ready to try some of these? Here's a person weightless. This is kind of fun. This is the space shuttle. So you're actually looking back and you're seeing part of the space shuttle there. There's an astronaut. This is a very massive thing, maybe a ton of stuff, right? There in space. And of course, although it doesn't have weight, it still has inertia, and so it still takes some oomph to move that thing around. And that's what the robotic arm, this might be the robotic arm coming in there and maneuvering it. But these things, they also have jet packs where they can maneuver things around like that. So that's somebody who's weightless, but not massless. What is the weight of a 26.2 gram European swallow? Do you suppose this has to be kilograms? You suppose that has to be kilograms? You have to divide